Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about my proposal final year project. So my title is Carbon Sequestration by Indirect Carbonation of Electric Arc Furnace Slag. So my supervisor is Prof. Dr. Insinyur Thomas Chong Shen Yao. My name is Muhammad Hairul Nizam bin Jamaluddin. My metric number is 181984. Proceed to the introduction. So there are 33.4 billion tons in 2011 of carbon emission comes from anthropogenic activities. Anthropogenic activities, that is activities that release the carbon emission to the atmosphere. So today there is by all accounts impressive logical proof that human exercises may cause environmental change because of the upgraded necessary impact taught by IPCC in 2001. So the level of carbon dioxide in atmospheric is changed from 200 part per million to 400 part per million, that make approximately 0.8 Celsius increase on global surface temperature, taught by ESDRPO in 2015. My background of study. Therefore, CCS strategies, that is carbon capture storage, been made to overcome this problem, such as improving energy efficiency, switching to low carbon fuels, utilizing renewable energy. So CCS technology is comprised of three steps: catch, transportation, and capacity. So CCS strategies divide by three. There is geologic storage, that in depleted oil and gas field, aquifers or coal bed seams, ocean storage, and mineral carbonation. So what I am doing for this study is basically about mineral carbonation. That is one of the example of the carbon sequestration and carbon capture strategy technology that can potentially store large amount of carbon dioxide in safe, permanent, and environmentally benign manner. That mineral carbonation also proposed by Seyfried in 1990. Okay, let's proceed to the problem statement. The problem is climate change. Climate change is actually from the carbon release emission that is assessed in atmosphere. So we have studied the alternative way for producing PCC more environmentally and less releasing of carbon dioxide. Actually, in industry of producing PCC from wollastonite, there is a calcination step that require 900 degrees Celsius. That is the step that release the main step that release very high of carbon dioxide. Let's proceed to the objective of this study. For the first, to compare the content of magnesium and calcium based on the different molarities with different timing and different molarities with different temperature by using ICP-AES, inductive coupled plasma, atomic emission spectroscopy after the leaching process. Second is to get the precipitated calcium carbonate by using injection of carbon dioxide. So for the third, to compare the amount of calcium carbonate that can be performed by using different molarities with different timing and different molarities with different temperature. Here the scope of study. In this study, I am using electric arc furnace slag that basically waste from iron and steel making. I am using the hydrochloric acid for the leaching with the electric arc furnace slag, that is for the extraction process. Before that, there are preliminary stage that I have to do. What I have to do is prepare the solvent of hydrochloric acid based on the molarity that I am needed. I proceed with the carbonation process by the injection of carbon dioxide, and the result from this, I can get the calcium carbonate. The main step in this study is extraction and carbonation, because the main study is indirect carbonation process. Here the literature review, we proceed the 2.1 carbon dioxide sequestration. The keyword the first keyword in this study. So we are divide to from carbon sequestration, we can divide into three: geological carbon sequestration, ocean carbon sequestration, mineral carbon sequestration. That is mineral carbonation. Here the factor that enhance carbon sequestration: change in future climates and causes negligible economic damage are the potential effect from anthropogenic greenhouse gas emission. So the carbon is essential for living organisms. They also stated that the main problem that needs an urgent global attention is how to control the large release of carbon dioxide to atmosphere and environment. So here, this is the process, carbon sequestration. So that is why carbon sequestration is important to overcome this problem. Geological carbon sequestration. It is functioned by the injection of gas of carbon dioxide to deep saline aquifers with a depth of between 800 to 1000 meters. When carbon dioxide is dissolved in situ in fluids or adsorbed, it will show the carbon dioxide was trapped and produce the impermeable layers such as cap rock, mudstone, or clays. If to make the leakage from this method become more difficult, because this method require pipeline, so pipeline to uh, to prevent from the leakage, the utilization of pore space must increase. So we proceed to the ocean carbon sequestration. Ocean storage is still in experimentation and does not mean in big scale, because the disadvantage from the ocean carbon sequestration is can change the pH of the ocean, so it will be affect the aquatic life in the ocean. So the technique is the carbon dioxide that been captured was injected directly to deep ocean. The method requires pipeline or ship that act as medium for transportation and send it to the storage site. So proceed with the mineral carbon sequestration. What am I studying in this final year project? As mentioned in the above, in 1990, Seyfried was proposed the idea of mineral carbonation or mineral sequestration of carbon dioxide. The reaction for this mineral sequestration is acid-base reaction. The main ion or rich ion in silicate minerals such as serpentine, wollastonite are magnesium and calcium. So to get serpentine or wollastonite, it will be require high cost. So to prevent or to overcome this problem, the problem of cost, we can just use the steel making slag, that is electric arc furnace slag, because it is less cost, it contains of magnesium and calcium. The content of magnesium and calcium in electric arc furnace slag is same with the wollastonite and serpentine. So, the main aim for mineral carbonation is to create a great net environmental benefit by minimize carbon dioxide in the atmosphere to help in avoiding the worst of the estimated dire impacts of climate change globally. So, this is indirect carbonation. Indirect carbonation is one of the method carbonation from mineral carbonation. Indirect carbonation have two steps, that is such as extraction and carbonation. Extraction of hydrochloric acid. So to achieve high extraction efficiency in indirect carbonation, excess acid is required. This is the last keyword, electric arc furnace slag. This is I am using electric arc furnace slag as a medium for reaction with hydrochloric acid in leaching process. This is the history of electric arc furnace slag. Herold was invented the electric arc furnace slag become important steel making process. These are some applications of electric arc furnace. Steelmaker was applied electric arc furnace to produce stainless steel, electrical steel, and special alloy. The content of electric arc furnace, that is major chemical constituent is calcium oxide and iron oxide. Besides of that, magnesium and calcium are the main major chemical constituent in electric arc furnace slag. So we proceed with the methodology. First, the preparation of slag is the preliminary stage, that is require three equipment, that is roll crusher, ball milling, sieve and shaker. This is quite long. So to prepare the slag become fine size, less than 90 micrometer, that is range between 63 micrometer to 90 micrometer. So we proceed to the leaching step, that use hot plate magnetic stirrer. With drying step, after the leaching step, it is much wet, so we have to dry it uh, by using the vacuum drying oven. So after drying, we have to filter the weight after and before the leaching. Okay, so for the fourth step is analyzing step by using ICP AES. And lastly, to get the precipitate is bicarbonation step by injection of carbon dioxide. That's all. Thank you.